So now with this, I know that I'm trying to find out what is dx over dt. Okay, so we need to find out what is dy over dt and dy over dx. Okay, so that I can then find out what is this one. Okay, so first we find out what is dy over dx. Okay, and we find that dy over dx will be 1 over square root 2x plus 5. Okay, for dy over dt, I already know that it is 3. So let me rewrite the formula here. This is 3. Dy over dx is 1 over square root 2x plus 5 times dx over dt. So dx over dt will be equals to 3 divided by 1 over square root 2x plus 5. And that will mean 3 times square root 2x plus 5. Okay. Now, in order to find out the exact value of dx over dt when y is equals to 3, okay, I must have the value of x because this is in terms of x. So what we need to do with this y equals to 3 is that we'll place it inside the original equation. Okay, such that 3 equals to square root 2x plus 5. Then we solve to find out what is x. And we find that x equals to 2. So therefore, when x equals to 2, your dx over dt will be 3 times square root of 9, and that will be 9. Okay, so we can then conclude the rate of change of x is 9 units per second. Okay. Alternatively, seeing that it's positive, you could also say the x is increasing at a rate of 9 units per second. Okay. Alright, any questions for this besides 13.4, question 3? Okay. It's really very mechanical, okay, for this topic itself. So the biggest thing that will help you move forward is to really figure this out. If you cannot figure this out, then the things will not fall into place already. Okay? So let's take a look at question 4. Question 4, we are given that y equals to 2x plus 1 over x plus 4. Okay? And then dx over dt is equals to 0.42 units per second. And we are asked to find the rate of change of y when x equals to 3. Okay? So we have dx over dt, we want to find dy over dt, and we are given y in terms of x. So with this y in terms of x, I know that I can differentiate to find dy over dx. So with these three items, I need to create the link between them. So again, okay, it is our setup. Right? Okay, so we see that our y is in the numerator. Okay, so dy over dx will usually always be in the center. Then after that, dx over dt over here, and dy over dt on the left. Okay, so then kind of like algebraically it seems to make sense, right? Okay, so now we will proceed with finding out what is your dy over dx first. Okay, since we already have dx over dt, because dy over dt is what we want to find. Okay, right here. Okay, so with y equals to 2x plus 1 over x plus 4, we can use our quotient rule. And we find that dy over dx will be 7 over x plus 4 bracket square. Okay. Then, using the so-called formula that we figure out, okay, dy over dx is 7 over x plus 4 square. Dx over dt, we have given it to be 0.42. So 7 times 0.42, you will get 147 over 50 x plus 4 square. Okay? When x is equals to 3, okay, this one has lesser steps since we're given the x value already. I simply have to just sub it inside your dy over dt. And we'll get 3 over 50. Or you can leave your answer as 0.06. And we conclude that okay, then the rate of change of y is 0.06 units per second. You may leave it in fraction also, okay? Or if you want to describe that y is increasing, that's fine as well. Helps us to warm up for this connected rates of change. Okay, and the key idea is really forming that formula itself. at try 9. Let me break down the question for you. Okay, the question says that there's an inverted right pyramid. Okay, in case you don't know what is a right pyramid is where the vertex, the top corner, okay, is directly above the center of the base. Okay, for all the pyramids that you cover in your syllabus in secondary school will always be right. Okay, it's not that it is seated on the right or the left, okay, but it is upright. Okay, that kind of right, right? So that's why you find this word usually when you describe a pyramid or a cone. Okay, otherwise it will be slanted. So for example, for a cone, a slanted one will be like that. Okay, then upright one will look like that. So the top is directly above the center. Okay, that's what it means by right pyramid. So square base of side 18 cm. Okay, so we know that all these are of the same length. And then the height is 30 cm. So the height is always measured from the center of the base to the vertex. Okay, so because this is drawn in a 3D manner, okay, so that's why this one it reaches at the center lah. Okay, but we know that the height is always from the bottom to the top. Then the question says that the water flows in at 5 cm³ per second. So we know that water is going in, and 5 cm³ per second, we know that the volume per second, okay, so this will refer to dV over dt. Okay, so dV over dt equals 5 cm³ per second. Okay, question asks how fast is the water level rising when water is 10 cm deep? So that means that when the water is 10 cm deep, we want to know what is the rate of the increase in the volume. Okay, you may be wondering why are we looking at this? Why are we looking at solving such a thing? Okay, first of all, you must understand that when it comes to a cone or a pyramid, okay, that looks like this, your water flows in. It can be at a constant rate, but the way it increases, okay, will not be constant because each part of the pyramid here, right, they have different volume. So at every juncture, at every height level, okay, the way the volume actually increases will actually be different. Which explains why we want to find out, okay, how fast is the water level rising when the water is at 10 cm deep. At this particular point, how fast is it going to be? Okay, so that is the whole question, what the question actually wants. Water level, okay, that is the speed of the water level rising is what we want to find. In other words, if I define, okay, this to be height itself, okay, any height of the water level to be h, maybe let me just label this as h. So we're looking at the speed. In other words, we're looking at dh over dt. Okay, so that's what we want to find. Okay, so we have dv over dt and we want to find dh over dt. We need to create that connection, okay, something that looks like this. Okay, so we have the both dt over here already because both of these are having the so-called denominator to be dt. What we are missing is this connecting piece, okay, that will likely be dv and dh. So we are missing this dv over dh. Okay, so these are the things that you need to connect together, okay, before we can move on. Right, so these are given information. We notice that we need the dv over dh. But how do we create the dv over dh when this question has no mention about volume in terms of h at all? In fact, this is a right pyramid. We have already learned in Sec 2 how to find the volume of a pyramid itself. Okay, so volume of a pyramid, if you recall, that will be 1/3 times base area times height. Okay, so this is what we have in Sec 2. So the base area in this case, because it is a square, so it will just be the length times length. Okay, so let me define some variables first. Let x cm be the length of base. defining x to be the length of the base, okay, h to be the height of the water level, and v to be the volume of the water. Okay, the amount of water in the pyramid itself will change, okay, for every height change and then the x change also. So V is being defined as the volume of water, not the volume of the pyramid. Okay. But the volume of the water will take the shape of the pyramid. Okay, that explains why we will be using this. So with these variables being defined, that means that in this particular context, our base area, since it is a square, that means it is having the area of x squared, because x times x, that's a formula for area of square, and then times the height h. Okay, so we get v equals to 1/3 x squared h. So just now as mentioned, we were missing the connecting piece of dv over dh in order to tie up my dh over dt and dv over dt. Okay, so how do we figure out our dv over dh when our formula over here is 1/3 x squared h? Okay, our x is a variable because x will definitely change when my height changes as well. So when the volume of water increases, your x will become longer, height will also become taller as well. So I cannot take it that x is actually a fixed constant, okay, because x will change according to h. Alright, so the challenge over here is how do we actually change my formula over here to be fully in terms of h. Before finding our dv over dh. Right? So that is the big challenge. Okay? So to overcome that challenge, right, is to identify similar figures. Okay? I need us to be able to observe that in a pyramid itself, okay, if I were to extract out a right angle triangle here, okay, this small right angle triangle, right, versus a big one, okay, so right in the center, sorry, this is a very, it's a 3D diagram now, okay, so need a little bit of visualization. I'm trying to visualize a right angle triangle from the center of the base to the side of the base, along the slanted part down to the vertex, okay, and then perpendicular down as well. Likewise over here. So if I take down those triangles, right, I'm looking at a triangle like that, and a big triangle like that. Okay. So this red triangle is a triangle that depends on the volume of water inside. So this height over here, it varies, it is your height, h, and then this length over here is only half the square. So this is x over 2. Okay, so this one is based on volume of water. Okay, this big triangle is based on the container itself. Okay, the actual container. So the entire height of the entire container will actually be 30 cm. And the entire base over here is actually 18, but we divide by 2, so that will be 9. Okay, so we need to be able to identify these two right angle triangles. And they are similar. Okay? Right? The goal of us doing this is to change my x variable over here into h, because I need to find out dv over dh in the end. What is stopping me was the x over here. Okay? By our similar triangle property, we know that they are proportional. By similar triangles, 30 over h is equals to 9 over x over 2. Okay? And we can cross multiply 30 times x over 2 equals to 9h. We want our x in terms of h, so this is 15x. So x is equals to 3 over 5h. Okay? So this is how we overcome changing our x into h. And therefore, our volume is now 3 over 5h bracket square times h itself. That would give us 3 over 25 h cubed. Okay, yeah. Why I divide by 2? Okay, because I'm using a right angle triangle only halfway. So x must divide by 2. So I forgot to bring out a pyramid. This is the whole pyramid, the square base. I'm only taking the triangle that's halfway through the center, because that will actually be similar. If you want to take the entire one, can I take the entire one? Let me see. If I take the entire one, versus, actually can also if you want to take the entire one, x and then this one will be h. This is going to be 18 h. Okay, I'm only taking halfway because let me try to do it in video, apply for all scenarios. If you want to take the entire triangle like that, an isosceles triangle, that's also possible. Doesn't change the answer as well. I think it's also fine. Just that I think for my usual practice, I will use a right angle triangle. Nothing wrong with doing that. Yep. Interesting. Actually, I never think of why is it that I always use right angle triangle. It's just my personal habit, I think. Okay, yeah. So I'm thinking of cones. Cones-wise, it should apply also. I don't think a question will ever be challenging such that they will give you a base that's rectangular. That will kill everyone in Singapore. Okay. They will rightfully give you a base that's square. Because once it's rectangle, then there are too many triangles to consider. So it's not possible. Okay. But yeah, you can consider a bigger triangle, a full triangle. This way is fine. Okay. Any other questions before I proceed? Next time you get it already. Okay. So now we have our volume in terms of H already. I can proceed to find out what is my dV over dH. Okay. So 3 over 25, bring down power 3 H squared. So 9 over 25 H squared. Okay. Then we can do our formula now. So we have to find, or rather we use dV over dt equals to dV over dH times dH over dt. Okay. dV over dt has been given to be 5. dV over dH is now 9 over 25 H squared. And dH over dt is what we want to find. Okay, so dH over dt will be 5 divided by 9 over 25 H squared. That will give us 125 over 9 H squared. And when the height is 10, that's what the question wants. Our dH over dt will be equals to 125 over 9 times 10 squared. And that comes out to be 5 over 36. So the height is increasing at a rate of 5 over 36 cm over second. I'll let you think through this for a moment before I go on to the next one. Okay. Any questions? Yep. Sorry. How is it that I get the similar triangle formula portion now? Okay. Similar triangles, the sides, the corresponding sides are proportional to each other. So the corresponding sides is 30 and H and 9 and X over 2. So 30 divided by H is equals to 9 over X over 2. Just the proportionality. Okay. You can of course do it the other way around. You want to take H divided by 30 equals to X over 2 divided by 9 is okay. Yeah. Right? It's a proportionality thing. Okay, they are corresponding sides are proportional. Okay. Any other questions? Right? Let's do another one more that requires similar triangle. Okay. Since we're already at this. Okay, let's take a look at exercise 13.4, question 14. Okay. drawing is not the best, but I try. Just cross-check. I try my best to draw. Hope you understand what it's talking about. Okay. So basically in this question, it says that there is a man who is 2 meters tall, extremely tall I feel. Okay, is walking away from a street lamp of height 7 meters. Okay. The best light bulb I can draw is the one I learned from physics, which looks like this. Okay. So he is walking away at a rate of 5/3 meter per second. Okay, that is the rate that he is walking. Then given that the top of the man's shadow, okay, so I draw him flat like that, this one is the shadow, okay, the top of his head is actually x meters away from the lamp, okay, so x meters. Then from the lamp, when he is y meters away from the lamp, okay, so when he is actually y meters away, the shadow will actually be x meters away. So in part I, we want to find out, okay, y in terms of x. Okay, so how could we go about doing that? We need to first identify some similar triangles. Okay, one pair of similar triangle that you can identify will be a right angle triangle. This one over here versus the big one, from the top of the shadow all the way to the lamp and then up and down. Okay, so we are looking at having a small one and then also a big one. Okay, so using this information, I see that this part which is here will have to be x minus y meters. Okay? And then the height here is 2 meters. Whereas for the big right angle triangle, I see that the base will actually be x here, and then the height here is 7 meters. Okay? So using our similar triangle property, I will find that the corresponding sides, which is x over x minus y, should be equals to 7/2. Okay? Question wants us to find y in terms of x. So I need to manipulate this to make y the subject. I do so by cross multiplying. y equals to 5/7x. Okay, so that's our answer for part I. Okay. Next, we look at part 2. Part 2 wants us to find the rate at which the top of the man's shadow is moving. Okay, so that means from here, okay, what is the rate that it is moving? And this distance to the lamp is actually x. So in other words, what the question is trying to ask for is to find out what is the x/dt. Okay. And then this 5/3 meter per second that is given to us, that is actually our dy/dt because it is based on the man himself. Okay, how far is he moving away from the lamp? Okay, so this value is your dy/dt. Okay, so we want to find the x/dt and we are given dy/dt. I now already have my y in terms of x. That will help me to find dy/dx. So in other words, with these three things now, I can form my formula to be dy/dt equals to dy/dx times dx/dt. Okay? So, proceeding to actually start solving, we first find out what is our dy/dx. We only get 5/7, so our x is entirely missing already. Okay, so then we find out what is our dx/dt. Equals to 5/7 times dx/dt. So we get dx/dt to be 7/3, that is 2 1/3. So the shadow is moving at a rate of 2 1/3 meter per second. question for the day and for this chapter. Okay, we're looking at try 10. So it says that a boat is being pulled back to the dock, okay, by a rope that is attached to the boat. Okay, so there is this pulley system over here. This boat is moving in this direction. Okay, it says that the vertical distance between pulley and the boat. So vertical distance refers to this direction. Okay, this distance here is actually 3 meters. The question says that the rope is actually being shortened, so being reduced in length at a rate of 0.75 meter per second. So this is going backwards at a rate of 0.75 meter per second. The question wants to know how fast is the boat moving, okay, which will be in this direction, okay, when the boat is 7.5 meters from the dock. Okay, so we want to find out what is this speed itself when we're looking at a distance of 7.5 meters away. Okay, let's start off with defining some variables. Okay, so I define x to be the length of the rope. So that means that this length over here is x itself. Okay, and y be the horizontal distance between the pulley and the boat. That means I'm looking at this distance. Okay, that we will call y. Okay, because x and y are things that are changing, what we are given is that the length of the rope is being decreased, okay, so that the boat can move in this direction. So I'm giving a variable x, okay, to help us define the value 0.75 meter per second. That will be our dx over dt. Okay, so what we're trying to find is actually dy over dt, okay, which is the speed of it moving backwards. Okay, so first of all, now that we know that dx over dt is what we're given and what we want to find is dy over dt, I need a formula that links up y and x together so that I can have dy over dx. Okay, so there needs to be that connection where I need dy over dx. Okay, so how do I figure out y in terms of x? So that is the big question. Okay, so let's take this, because this diagram is not drawn very well. Okay, we take it as a right angle triangle. Okay, maybe instead of having y this way up, y will just take it as here. It's parallel. Okay, so y is here also. Because you don't know where exactly is the measurement taken from as well. Okay, so we take y to be here, y to be here as well. From the frontmost edge of the boat. Okay, so we see a right angle triangle here. A right angle triangle, we think of Pythagoras theorem. Okay, other than Toakaso, we think of right angle triangle and with Pythagoras theorem. So this to be defined as y. This was defined as x already, and this is fixed at 3 meters. Your pulley and your boat distance never changes. Okay, so by our Pythagoras theorem, hypotenuse will be x squared equals to y squared plus 3 squared. Okay, in other words, that is y squared plus 9, and y squared will be equals to x squared minus 9. Okay, so we have y equals to square root x squared minus 9. formula for y in terms of x so that we can generate a dy over dx in order to create that formula that we need. Okay? So with y equals to square root x squared minus 9, which is also x squared minus 9 to the power of half, I can find out dy over dx to be half x squared minus 9 to the power of negative half and 2x. And so our dy over dx will be x over x squared minus 9. So, since our numerator for dy over dx is having y at the top, so we start with dy over dt equals to dy over dx times dx over dt. Okay, and dy over dx will be x over x squared minus 9 square root times dx over dt will be 0.75. And therefore, we will get 0.75x over square root x squared minus 9 for our dy over dt. Question is asking, what is dy over dt when this distance here, which is y, is 7.5 meters? So, when y equals to 7.5 meters, we first find out what is x in order to substitute inside here. So x squared equals to 7.5 squared plus 9. That would give us 65.25. I'm going to use the exact value. And we find that it is 0.808. So therefore, our boat is moving back to the dock at a speed of 0.808 meter per second. So to just quickly wrap up, alright, in our connected rates of change, we hinge it a lot on our formulation of this formula, okay? But sometimes we may need to actually create the formula for y in terms of x or whatever it is, okay? So we will need our similar figure sometimes, or sometimes even our Pythagoras theorem, okay? So we have seen the use of similar triangles, okay, to actually create the formula, as well as to use our Pythagoras theorem in order to create the formula. Okay, So I'd like you to go back home and give it a try to consolidate what we learned. Okay. So to continue on the foolscap paper that you have done for exercise 13.4, please complete question 9, 10, and 11. Okay. Can we complete this for submission by Friday, please? Because that's the last day of school already. Okay. So please submit this by Friday. Okay. Then tomorrow